Здравствуйте, дорогие слушатели. Меня зовут Анна Селезнева, я куратор факультета психологии Высшей школы «Среда, обучения». И сегодня у нас с вами очередная лекция в рамках проекта «Встречи вне границ». Мы очень рады, что наш проект уже популярен не только среди наших студентов, но и находит большой отклик среди всех людей, которые интересуются психологией. И мы с вами снова и снова доказываем, что дистанционный формат общения, он важен и он расширяет границы. Ну а сегодня с нами Барбара Тверски. Она является членом Американской академии искусств и наук, Общества экспериментальной психологии, Общества когнитивных наук, Ассоциации психологических наук. Барбара получила степень в области психологии в Мичиганском университете. Ее исследования посвящены памяти, языку, а также пространственному познанию, схематическому мышлению, жестам и даже творчеству. А тема сегодняшней лекции — жесты, как они меняют наши мысли и мысли других. Ну, вообще жесты, они являются действительно очень актуальными для нас. Мы их используем каждый день и передаем с помощью жестов наше эмоциональное состояние, сообщаем о нем собеседнику. И в психологии это также является очень важным. Благодаря жестам психолог может понять состояние клиента, может распознать иногда даже ложь своего клиента, и также жесты иногда могут укрепить терапевтический альянс. Вот, поэтому предлагаю начать эту интересную лекцию. Я напоминаю, что на протяжении всего сегодняшнего вебинара я буду с вами, буду смотреть вопросы, собирать их, поэтому прошу их задавать на русском. У нас перевод синхронный, поэтому все вопросы будут переданы. Вот, и всем желаю прекрасной лекции.
So thank you very much for inviting me and for that nice introduction. It'll be a while before I get to gesture, but I will get there. And part of the reason is I understand you're a school of arts, psychology, and design. And I'd like to speak to some of those interests as well as gesture. So I will share a screen and find my talk. Okay, there it is. And I should say too, because again, I know you're interested in the arts and that there's some interest in comics, that I do have a special section on comics that I could add at the end if there's time, but I don't want to wear you out with too much talk. So I will begin. So all creatures, all living things must move and act in space to survive. And more examples. Even plants, if they don't move toward the sun and away from the wind, they won't last. So everything needs to move and act in space to survive. And the contention of a book I wrote not long ago that's meant for a general audience called Mind in Motion. I believe it was translated into Russian. It's been translated into several languages. So in that book, I argue that all thought begins as spatial thought because space is essential for survival. The book covers the spaces of action, a section on brain, spatial abilities, who's good, who isn't, how do you know? Perspective, which is a key issue both in actual perception of space and imagined perception of space, and then imagining other people's perspectives on many issues. So perspective is key. I won't get to talk about that. It would be another talk. There's also sections on gesture, on language, on cognitive tools, the things we create in the world to improve our own cognition, on creativity, on the design of the world. So some of the latter I'll touch on today, but there's more in the book. So space is special. It's supramodal in human beings. We know about space not just from vision. Blind people can navigate better than I can in many cases. So we know space from many different senses, from hearing, from touch, from the feeling of things on our feet, from wind. There are all kinds of cues to where we are in space. And again, people without vision can have excellent spatial imaginations. So knowing about space is essential to survival. If we couldn't find a way to get food in our mouths or find our way home at night, we'd be dependent on other people forever. Spatial knowledge is so fundamental and basic, even if it's erroneous, it's still so fundamental and basic that it becomes the foundation for other knowledge, for our understanding of social relations, for our understanding of physics, for our understanding of just about everything. What's interesting from a psychological point of view is that our knowledge of space isn't like geometry or physical measurement. We don't come equipped with those measuring instruments, so that our knowledge of space is estimated and computed from our other senses. And it's systematically distorted because of perception and action, which are deeply coupled. And I'll touch on that only briefly here. So the spaces of action, I've distinguished three, and they're by the foundation in perception and in action, and they're pretty well recognized. So there's the space of the body. You know, how do we think about our body and our body in motion? There's the space around the body that we can see. It's in reach of hand or eyes. So it's immediately around us, usually conceived of in 3 dimensions. Then there's the space of exploration, of the larger spaces that we get to by foot or bicycle or automobile or airplane. And these are spaces that can't be experienced from one position in space, the way the space around the body can be. They have to be pieced together from many different experiences. And some of them are actual experiences, and some are things we've read about or learned from maps. So they're learned in a multitude of ways. And again, each of these representations is distorted by the coupled perception and action in them. So I'll start with the space of the body. So children around the world, if asked to draw a human figure, and many do spontaneously, draw things like this. They usually have 2 legs, not just one. This sort of has 2 legs. They're rather short, but they capture the essential parts of the body, the head, the trunk, the legs, the arms, the hands, and don't have much representation of the rest of the body. And things aren't proportional to the actual sizes in the body. And the parts that are exaggerated in children's drawings or minimized are also exaggerated in the cortex, in sensory cortex, and in motor cortex that go across the crown of your head, one facing the other. Again, there's more representation in the cortex, both sensory and motor, for our hands and our faces, than for our backs and our legs. So then there's the space around the body. And here we have, again, bases for distortions, and that's the asymmetries of the body axes. We have 3 body axes, a head-foot axis that's asymmetric, a front-back axis that's very asymmetric, and a left-right axis that has asymmetries, but far less important than the front and the back, which separate the world that can be seen and acted on from the world that's hard to perceive, or the up-down axis that's conferred by gravity and again affects all of our actions in space. So finally, there's the space of exploration that's put together from many different sources. So we've studied each of those spaces, we and other people, and looked at the kinds of distortions that are in our representations of them, and again, attributed them to perception and action. So then brain, and recent work on the brain, some of which won a Nobel Prize for the Mosher's postdoctoral students working in John O'Keefe's lab in London. The 3 of them shared a Nobel Prize for finding basically place cells and grid cells in hippocampus of rats or of rodents. And we have these sorts of things in many other species, including people. So hippocampus, which you probably know is important for establishing new memories and for interrelating many different aspects of memories, retrieving them when we need to, but establishing memories and retrieving them. In hippocampus of rodents, there are single cells that fire when the rodent is in particular places in an environment. So the rats are equipped with sensors on their head, and the sensors actually have electrodes into individual neurons. The rat becomes oblivious to that helmet that it's wearing and wanders around space freely. And these single cells in hippocampus fire when the rat is in one place, but not another. So there's a whole series of these place cells for the different places that the rat will occupy in natural exploration. So that's not the whole story. There's been considerable work on that, on the place cells since then. That's fascinating, and work on humans. So these place cells aren't arrayed spatially. So although there were claims that this was a sort of cognitive map, it really wasn't, because things weren't mapped in the brain and they have campus the way they're mapped in the world. So the Mosher's discovered right next door to hippocampus in entorhinal cortex, 1 synapse away, grid cells that do map the place cells spatially. And you can see that on the right. These are, the red is the firing, the cells that are firing, and same with the place cells. And you can see that they form a sort of grid of spatial relations of the place cells. So this was an extraordinary finding and led to an explosion of research. What became extremely interesting is a bit of this research has been done on humans. So the reason it can be done on humans is that humans awaiting brain surgery often volunteer to have the electrodes placed in other parts of their brain. In any case, before the brain surgery, often this is done anyway, because you don't want to disturb an area, you don't want to surgically remove or disenable a part of the cortex that's important for speech or other important cognitive or emotional functions. So often electrodes are placed in different parts of the brain so that it's clear that you're not going to damage a critical part. So we know about place cells and grid cells in humans. And what's more, we know that they encode more than space. So single cells in hippocampus fire in humans, not just for places, they also fire for events in time, people, and ideas. And what each of these single cells does is gather information from all over the cortex, information about sight, about smell, about reward, and so forth, and gather them into a single cell so that all of these different aspects are associated with the place cells. So the fact that in humans they fire for events, people, and ideas is quite exciting. And then it turns out that the grid cells map relations that are temporal, social, and conceptual. So those same grid cells that are used to map spatial relations also map temporal relations, social relations, and conceptual relations. And this seems to be the clincher for arguing that spatial thinking is fundamental to abstract thought. Okay, we'll leave the brain. Just say again that the same brain structures that represent place and relations or paths between places and real space represent time, people, and ideas in temporal, social, and conceptual space. And these become the building blocks of all thinking. The elements or places, ideas, and people, the elements that are captured, that are multidimensional, and then the relations between the elements, how they're arrayed one next to the other. Okay, and the analogy I came up with is that the hippocampus establishes checkers for ideas, and what the grid cells do is they're like a checkerboard, and they map the relations among ideas. And you can see this sort of mapping in road networks, family trees, social networks. So again, we have people and relations to other people. This was drawn by one of our students. We asked for essentially for them to map their social relations, and they usually put themselves in the middle, and often family is above them, and their friends, their contemporaries, are beside them. So they're using space in meaningful ways. Phylogenetic tree of life, again, a network. This is a poster from the Museum of Modern Art illustrating the relations between 20th century modern art movements, how they interacted with each other, again, a network. And this is art. This is an artist named Mark Lombardi. That particular network, he draws many, they're quite beautiful. They take up a whole wall, and they're labeled, and they're usually political and economic relations. And you see people looking, scrutinizing them very closely, and following all the relations that are social and economic. And of course, these are used now in establishing social networks and in making inferences about who's influential in social networks. How does information travel? How do fads travel, and so forth? How does misinformation travel? So thought comes from actions in space. Our feet go from place to place along paths, just as our minds go from thought to thought along conceptual relations. And our hands act on ideas, just as our minds act, our hands act on things, just as our minds act on ideas. So these two sets of concepts, one about what our feet do, one about our hands do, get reflected in language. And you'll have to tell me if they work in Russian. I know that I don't speak Russian, although my grandparents did. but I do speak several other languages, and this does work in those other languages. I'll give you examples from English, and maybe our talented interpreter has similar ones in Russian. So we talk about actions on ideas as if they were actions on objects, and these get expressed in gestures as well. We can raise ideas, we can pull them together, we can tear them apart, we can turn them upside down, we can toss them around, and so forth. It's extremely hard, in English at least, to talk about actions on ideas without using the language of actions on objects. And again, these are expressed in gestures that pop out of our body naturally without asking them to come. We might choose words deliberately, although for the most part they pop out of our minds, but the gestures certainly just pop out of our bodies. We have figurative spaces. We talk about being out of depth when we can't understand a problem. We talk about being at the top of the class or feeling up. When we feel up, we stand straight and bounce around. When we fall into a depression, our bodies crumple. And again, we're falling into a depression. So that axis of gravity, being up, being down, is replete with meaning. We talk about thinking out of the box, unconstrained, different from out of depth. And again, these kinds of figurative spaces we use quite frequently in talking about thinking. And again, they're often accompanied by appropriate gestures. The mind is too small. When thoughts overwhelm the mind puts thought into the world. And the mind can put thought into the world in words, as I'm doing now, in gestures and in graphics. And I'm going to be most interested, I've spoken about words, I'm going to be most interested here in gesture and graphics. So these are cognitive tools, the things we put out into the world, and we can perceive them and act on them the way we can perceive and act on things that are already out in the world. These are cognitive tools, and they're created to augment thought and to communicate thought. Cognitive tools expand the mind. They offload memory and information processing. It's very difficult to multiply 2-3-digit numbers without pencil and paper. So that putting our calculations on pencil and paper or an abacus helps us, augments the mind way beyond what the mind could do by itself. This is one of the huge advantages that humans have over other animals, and it's one of the major ways that we've succeeded in killing off all too many other species in the world. Okay, cognitive tools use space to represent literal and metaphoric space and actions. I'll talk more about that and give you many examples. They promote comprehension, inference, discovery, creation, and collaboration. Again, more to come on that. They seem to be uniquely human. There are, of course, examples of bees doing dances to show other bees where to go to collect pollen. There are animals that mark their territory. I used to be a runner, and apparently I used to run into the territory of a certain crow that would attack me anytime I came near the crow's territory, which I thought was my territory for running. But those are very limited uses of external ways of externalizing the mind. They don't have the range and depth and plasticity of the sorts of cognitive tools that we create and continue to create. So I want to show you now gestures, one way of augmenting the mind, and it will be in gestures. And these are experiments done in my laboratory with a bunch of graduate students, hardworking, talented. And in each case, we put a student, another student, a participant, alone in a room, and we ask them to read a text. The first one that I'll show you is a description of an environment. And we asked them to read the text and to read it 3-4 times because they were going to be tested. And in fact, they were tested and the test was hard. So they worked hard at learning the materials. These are students. Students work hard. They're good at learning, but they work hard at it. So this is what the first example we'll be reading. It's only part of it. This is about a quarter or a fifth of what she read. And it's a description of a town. Etna is a charming town nestled in an attractive valley, entered on River Highway. River Highway runs east-west at the southern edge of the town of Etna. Toward the eastern border, River Highway intersects with Mountain Road, which runs north of it. At the northwest corner of the intersection is a gas station. North of the gas station, Mountain Road will intersect with Maple Avenue, which runs west. It keeps going. The questions were taken directly from the text, or they were implied by the text. So that if north of the gas station is in the text, we might ask what's south of Mountain Road, and so that it required making an inference from the text. So on the whole, people answered quite well on the text, around 75%. But what mattered in performance was whether or not they gestured. So I'll show you now one student gesturing. So she's reading the text and oops, sorry, let me go back. She's reading the text. Nobody told her to gesture. People told her just to learn. She's not looking at her hands. This is spatial motor, but her hands are essentially making a map of what she's reading. She's making lines for the paths between the landmarks, and she's making those little circle things she just made one, for the places. She's doing this repetitively as she reads the description. And again, it's not spontaneous, it's completely spontaneous. About 75% of our participants did it. When they did it, they performed better on the test. And we think the text is hard. I think you thought so too, reading it. I think it's hard. But what the hands are doing is they're creating a model of what's described in the text, a spatial motor model. And we think they're using their hands to translate the words into thought. So I'll show you another example. This is somebody reading a mechanical system. We tried, by the way, many environments and many mechanical systems. We've done this sort of study many times. So this is a description of how a car brake works. They don't see a diagram. They have to figure it out from the reading. So from the brake fluid reservoir, brake fluid enters and travels sideways and down the brake tubes. As the brake fluid accumulates at the bottom of the tube, pressure is exerted on the small pistons inside the wheel cylinders. This causes the pistons to push outward toward the drum brake. Okay, and as I read it, I find it, I'm having to resist making gestures for you to understand it. And our participants again made gestures as they read. So this is one student reading that description. So now he's gesturing the same thing, but much smaller. And the same thing in bigger. And you can see he's studying it. He's not looking at his hands. That's not a gesture. He's not looking at his hands, but he's making gestures with his body. He's quite dramatic. Some people made tiny ones with their hands or drew on the desktop. People do it quite differently. But what they do in general is make a model of what they're reading. And again, it improves performance. Here's one more case. This is a student reading a description of several events happening at the same time. So there are 3 sets of events happening at 3 different times. And what she's doing with her hands is she will be doing here, I'll start it, is she's essentially making a matrix in the air, a table of the different events and the times. So she is looking at her hands, or she's looking at the image of the matrix on the table that she's creating, because what she's creating is sort of above the table. And again, people did this differently. There were people that used the knuckles of their hands like a table, or they drew on the palm of their hand to make a table, or they drew on the desktop to make a table. But in general, they were making gestures of the material that they were reading. What was interesting to us, another student went on to do a dissertation, and she compared reading a description with studying a diagram. So instead of reading a description of the parallel events in time, they actually saw a matrix with that information. And one theory of gestures says that gestures are done to create a visual image, in which case if we give them a visual image, they shouldn't gesture. But that wasn't the case. Even with a diagram, people gestured no less than when they got a description, and their gestures were the same. Again, the gestures created a model. So even seeing a diagram isn't sufficient. You need to internalize that diagram, and you do it by creating a model with your hands. Okay, so gestures model the situation described in the text. The models are spatial motor, not visual. And we ran another series of studies preventing gesture. We asked people to sit in their hands while they were studying, and those people performed worse. So again, what seems to me phenomenologically watching the students is that gesture translates language into thought. So gestures also promote collaboration. I hope I can get this going. Yes, these are 2 students at Stanford University. Stanford has a history of earthquakes, so it's very real. Everybody undergoes some sort of training and preparation for earthquakes. And these students were looking at a map of the campus. They were told there had been an earthquake, that there were wounded people at various parts of the campus, that certain roads were blocked off. And what they had to do was find a route through the campus to collect as many wounded people as quickly as possible. So one group worked together in this way. They had a shared map that they could gesture on, and then they collectively drew a map. Another group had a shower curtain between them. So they couldn't see each other, they could hear each other, they couldn't work on the same map. Importantly, they couldn't gesture. And that group performed far worse. Their maps, they thought they had come to agreement on a route by speaking, but there were errors, discrepancies between them a third of the time. It's very hard to come to agreement on to understand different routes from language alone. The gestures disambiguate and clarify exactly what the path is. The group that had the shower curtain between them were less happy with the collaboration. They enjoyed it far less, and they were working independently most of the time. Whereas the group that was unimpeded could see each other and see each other's gestures were much happier and always worked together and more collaboratively. There were more interchanges and shorter ones. It was a real collaboration. You will see when you watch the video that the gestures form the basis of the conversation. They're not looking at each other. They're looking at the hands on the piece of paper, and they're waiting for each other to finish before they jump in. So they're taking turns on the gesturing, just as we are taught to take turns on the speaking. Okay, let me try to get this going for you. There. The sound is unimportant.
If you can, yeah, come down like this.
You can see that they're annotating each other's routes. They're using three kinds of gestures, pointing to places and lines for routes, the way the learners were in the first video. They're also using what we call sweeps, which are kind of two-dimensional gestures to indicate they don't have to go to this part of the campus. Okay. So gestures promote the collaboration. They're more precise than the words. And again, people look at each other's hands, not their faces. The hands take turns. So you look at a fast-moving game like basketball. These players are phenomenal. They're understanding where their own team is, where the other team is. They're signaling to their own team in a way that the other team can't understand. If they had to talk, they'd never play. It would take far too much time. All the communication is through their bodies and their faces and their hands, and it's subtle and quick. Okay, I've talked about gestures for self, which are somewhat surprising to people, that our gestures for ourselves help us think and help us learn. I mean, if we watch people walking in the streets, talking on the phone to nobody present, often they're gesturing. So we're used to seeing people gesturing on the streets on their phones, and it looks normal. But gestures are also important for other people and for their understanding. Lots of studies have shown that, not just our own. We found that they're especially important for action. This is another study. Students were watching a videoed explanation of how a car engine. Half saw action gestures, describing the carburetors going up and down, or there's an explosion. Half saw structure gestures, the shape of the carburetor. And later there was otherwise they had the same verbal script. Then there was a true-false test of the structure and the action. The true-false test could be passed just from the language. You didn't need to see the gestures. Nevertheless, those who saw action gestures performed better on the action test. It had no effect on structure gestures because structure is easy for people. Action is hard. We know that from many other studies. Then we looked at their visual explanations of the engine, and we made them ask them to make a video explanation and of the engine so someone else could understand it. We also asked them to draw to make a visual explanation of the engine. And I'll show you those. This is structure gestures. I don't have a video showing it, but you can see that there's a schematic diagram. And then this man was reading the explanation or explaining, and he used different gestures for structure and action. Sorry, I do have it. That structure.
Of the crankshaft.
Okay, then let me get action.
This small explosion pushes the piston.
So you get an idea, yeah,
in-
of
in
two
this-
actions there.
This,
So as I said, viewing the action gestures, they got more action questions correct. And there was far more action in the visual explanations, in the videoed explanations, and in their words. I'll say more. It was especially important in the videoed explanations. So they used the ones who used action gestures used more gestures, both for action and for structure. Their gestures weren't imitations of what they saw. They were inventions for the most part. So they internalized the action, then re-expressed it in their own way. They used more action words. They didn't hear more action words, but they used more action words. So those action gestures gave them a far deeper understanding of the action of the engine than the structure gestures or than no gestures. Let me show you now their visual explanations. This is someone who saw structure gestures. It's just a bunch of labeled parts. Another one. This is someone who saw action gestures. You can see the explosion. You can see the air bubbles in the carburetor. You see lots of arrows. And they used far more arrows, those who'd seen the action gestures. And arrows are an excellent way of indicating action. So there were far more arrows. They also got the 5 stages of the process better than the people who saw the structure gestures. You can see there are 5 stages here. And again, the 5 stages were mentioned in the speaking, but not in no other way. But those who saw action gestures understood that better, partly because each stage is a different action. Here's another one. Again, more depictions of action and far more arrows. So gestures and graphics both enhance comprehension and learning for oneself and for others. I gave you one example. We have lots more. You can think about graphics on paper as frozen gestures. The advantage that they have over gestures is that they can be scrutinized. You can study them again and again, and you can alter them. Gestures disappear. They're especially good for representing action. Action is a problem on the page, and animations don't always solve that. That's a whole nother lecture and another time, but we've written and done research on that. Animations are problematic unless they're properly edited. So gestures are good for representing action, but on the other hand, graphics can be studied and scrutinized. So this is a study in graphics for explaining. Students were taught chemical bonding. This is 12-year-olds. They were taught over several days and using many different forms of explanation. Then they were tested on their knowledge of chemical bonding and then divided into 2 groups. This experiment was done several times. Half made visual explanations of chemical bonding and half made verbal explanations of chemical bonding, the usual way that students are tested. After making the explanations, they were retested. Both groups improved, even though they had no more material for study. So making an explanation led to better learning. Just making the explanation without studying the material, but the visual explanation group improved much more. So here are the data on the left, the first test before making an explanation, the groups were quite equal. The blue is the group making the visual explanations, the reddish color is the group making the verbal explanations. After they made the explanation, you can see both groups improve on the knowledge test, but the visual explanation group, the blue bar, is much higher. Why are visual? Here are some examples of visual explanations. And here's another one, sharks grabbing electrons, more peaceful. These are stick figures giving electrons, and boiling pots, changing the temperature. So that you can see these visual explanations came from inside. They weren't things the students had seen. There are no sharks in the textbook and no stick people in the textbook. The students invented these, and it turned out that their visual explanations had more of the structural information, but also more of the behavioral and causal information than the verbal explanations that look like this, just one word after another. So the visual explanations are better partly because there's a natural mapping from meaning to space, from elements and relations in the conceptual model of chemical bonding to elements and relations on the page. So both explanations require you to abstract the essentials, but somehow it was better with the visual explanation. Partly, at least, we think, because there's a check for completeness. Is everything there that I need to make an explanation? It's right there in front of your eyes in an array that's compatible for the way you think. It also gives you a check for coherence. Is it acting, behaving, causing in a way that makes sense, or is something not quite right? It gives you a check for coherence. A string of words doesn't give you an easy check for completeness or an easy check for coherence. What a diagram does also, it encourages inferences. And we've shown this over and over again in many, many different situations, that diagrams encourage inferences, and different forms of diagrams encourage different kinds of inferences. So this is important for teaching and learning, for discovery in many domains. In this case, they encouraged inferences from the structure to the function. So graphics, this is a map of the London Underground made in the 30s, and it's become a model for underground maps all over the world. It shows you the places in circles and the paths in lines. Distance isn't very accurate and direction is not very accurate, but so don't use it for navigating the ground, although I have and it worked. But because distance and direction aren't there, it's distorting. But if you're just navigating the tube, the underground, it's extremely useful. You don't need the other information. The man that designed this had previously designed electrical circuits. So I think it's not accidental that he came up with this way of displaying the underground tracks. So clear graphics schematize, they eliminate the irrelevant, they capture and even exaggerate and distort the essential. Often they show multiple perspectives. This one doesn't. I'll show you others that do. And they're multimodal. They have words in them, not sentences, but they have all kinds of words. They may have symbols as well. So they're multimedia. And in this way, they're like natural conversation, which is also multimodal, not just language. Okay, I'm running short on time. So tools of visual communication are the tools of spatial thinking. There are spatial relations and there are elements that are marks. And because we're so good at understanding metaphoric uses of space, these can convey meaning directly, whether they're spatial or abstract. The vertical is loaded because of gravity. So up is more good, powerful. It takes strength to go up and health to go up and so forth. The horizontal is more neutral. It's influenced by reading order. Again, many experiments that show that. Marks in space can be iconic. In other words, I'm using that not in a Peircean sense. They can look like what they're represented. They can be figurative, like scales of justice are representing justice. They can be schematic, like a dot. They can be symbolic, like a word. And the critical, the basic elements of visual diagrams are points for places and ideas, lines for paths or relations, arrows for asymmetric lines, and then boxes or circles or blobs for sets or areas. And again, there are parallels in gesture. And we've shown that these basic elements are understood in many different cultures. We've asked people to create diagrams using them and other people to understand them so that we know it's a form of empirical semantics. And we know from those studies that these sorts of elementary lines and boxes and dots represent abstract relations that are quite comprehensible, at least to people who have been schooled. There's even evidence that dots and lines are understood by people who've never seen a book. Okay, proximity is also important. Closeness in space represents closeness in human relations, in conceptual relations, centrality, and then directionality. So diagrams go way, or visual representations of thought put out in the world go back far earlier than written language. There's the oldest map keeps getting discovered, and this is the most recent discovery of the oldest map. It's 14,000 years ago. It's a tiny block about, well, I'm going to give it in inches, 2 inches by 1 inch. So what about 4 centimeters by 2 centimeters? So it's a tiny stone. It's engraved, it was found in a cave in Spain. It's engraved with a map of the area outside the cave. So you can see hills, rivers, even goats or some other kind of creature grazing on the land. So in old maps, many of them have this form. This was the previous oldest map found in Mesopotamia. This is after writing was invented. You see writing at the bottom. This map shows 2 perspectives. It shows an overview of paths and a frontal view of landmarks. And that's quite common. The geographers and the linguists and the psychologists don't like mixing perspectives, but people do it with ease, even children. Another kind of map is holding up your hand and indicating places on it. This was used by Native Americans in the northeast of the US and probably used in many other places. We represent space, we represent time. This is Chauvet. It's going back, I can't read it, 35,000 years, representing a stampede. These sorts of representations of animals, people, often people with bows and arrows, are found all over the world in caves, on petroglyphs, and so forth, everywhere. They aren't all quite as beautiful as Chauvet, but they are found. And why they're deep inside caves, and the pigments had to be tried many times to know that they would stick on the cave wall. They've lasted 35,000 years And in some cases, far more. There are caves discovered in Africa that go back 75,000 years and still have pigments. It's all mysterious. So there are also space-time explanations. This is making bread in an Egyptian tomb. It's only part of it, but it shows making bread from growing wheat, threshing wheat, carrying it to be milled, baking it, and so forth. What it's doing in an Egyptian tomb, again, a mystery. Number, this is going back 70,000 to 100,000 years. These are tallies of sorts on rocks. We find them on bones, again, going back quite far. Not clear what they were representing, although later examples are clearly tallies, a rudimentary way of expressing number. Expressing numbers the way we're used to took many thousands of years to develop. Okay, I'm going to skip kinds of discourse, stories. I'm going to skip that. I'm going to jump now to graphics. I can talk more about it in the context of comics. Going back to graphics and gesture. For the most part, I've talked about clear graphics and gestures, and they're important for providing clear guidance. How does a car brake work? How does chemical bonding happen? How can you get around in the underground? How can you put together a TV card or a piece of furniture? We've also studied that. So you want clear diagrams and maps and charts for clear guidance so people don't make mistakes. But there are other cases where you want messiness, and these are cases for discovery. So if you're a scientist analyzing data, you want raw data, so you can kind of try to see patterns in the raw data, and you want to look at it every which way, because you might discover something by exploring the data that you wouldn't see if the data were cleaned up. Similarly, designers, artists like the messy sketches, and the ambiguity in the sketches, by definition, allows for many interpretations. So we studied Masaki Suwa, and I studied architects, experienced ones, novice ones. We asked them to design a museum on a particular site. They had great fun trying to design it, and they made many sketches, and a series of them. So we let them design, we videotaped it, and afterward we had them go through the videotapes explaining what they were thinking as they were drawing. It turns out they can't draw and think aloud at the same time. Words get in the way. This is a conversation between the eye and the hand in the page, and language interferes. And we're going to hear the same thing from artists. So the architects would look back at their sketches and see things in them that they hadn't intended. So experienced architects who can read things that aren't there would, and this is true of chess players, of musicians, and so forth, they can make inferences that aren't directly represented in a diagram. Novices find that difficult, but the experienced architects would see that the traffic is going to be bad in rush hour, or they would see the light would not fall well in the winter. These are things that experience allows you to do. The novice architects might see that there's a pattern, a triangle at the bottom, and they might use that as a motif. So the inexperienced architects could make perceptual inferences, the experienced ones could make conceptual ones, but they both relied on the sketches to make inferences. They would draw and study their drawings and then make a new one. They'd come up with new ideas from looking at their own drawings. And that was a productive cycle. The more they got new ideas, the more they drew, the more they drew, the more ideas they got. And again, the experienced architects were better at that than the inexperienced. but it's the ambiguity that allows reinterpretation. And again, we've gone on to study that in many different ways. Architects make the discoveries when they reconfigure what they're seeing. So they rearrange it in their mind as they're looking, and that helps them make new discoveries, or that's what they say. So Andrea Kantrowitz, a former graduate student, a remarkable artist and art educator, for her dissertation studied experienced drawers, artists who've been drawing for many years and make a career out of it. And she did something quite similar to what Masaki and I did. She had them draw whatever they wanted for half an hour. She videotaped them, and then she looked at the videotapes with them, and they commented on what they were thinking. Again, they couldn't draw and think at the same time. They said things like, our ideas emerge from the page as they study. These are some of the things they said. Drawing is creating something from nothing. Drawing enters other worlds. You create a world and then you play with it. Drawing gets a life of its own. Drawing turns into other drawings. It drives itself. Drawing is exploration, finding things, discovering. Drawing focuses attention. It engages. Drawing calms. Drawing is fun, playful. Drawing is safe. And some of them even said, I deliberately get myself in danger. I draw something and I don't know how I'm going to get out of it, and I'll find a way. And if I don't find a way, I'll draw something else. Kentridge, one of the finest artists alive today, if not the finest, and I urge you to go to YouTube and look at his videos. They're remarkable. And for him, drawing is a key part of his practice. He said he's no good with paint, no good with color, but drawing is the way he thinks. So he says drawing is, I'm quoting him, slow motion version of thought. It's doubting, leaping, excavating, waiting. I lost that quote irrevocably. So then, pardon, I'm sorry about that one. I don't remember it. So drawing is a multi-layered highway of consciousness, where one lane has one thought, but driving up behind and overtaking it is a completely different thought. And I draw the way I think. So, and he has much more to say. This is from a lovely, he's also a brilliant lecturer. He's a brilliant actor and a brilliant producer, director, creator of events. He's truly gifted. So this is the way the world, that nature gives us in the world, minus the concrete. This is the world as humans design it. And this is more the world that we design. Think how different our world is from the world of our cave-dwelling ancestors. Even if they made beautiful drawings on the cave, they didn't have bookshelves, and they didn't have shelves for their kitchen equipment. They didn't have supermarkets with everything organized into categories and hierarchies and orders in the supermarket. They might have lined up their tools, but the richness of representations and organizations that we experience in every room of our house and in the world is extraordinary. And again, it's representing categories, hierarchies, orders. It's also representing themes. This is a kind of typical American house, a floor plan, and in each room has objects from many different categories that serve the same function. So everything in the bathroom is for cleaning and grooming, but it's things from very different categories. Similarly, the kitchen is for preparing and eating food, but it has things from many different categories organized for cooking. So we have themes. They're an important part of our life, and they're an important part of the way we organize space. They're a clue to archaeologists. The way people organize their spaces are clues to archaeologists about the way they lived, the kinds of societies they lived in. We also have in our table settings one-to-one correspondences, repetitions, cycles, embeddings. We have them in our buildings. Every balcony has a room and it has pillars and windows. They're one-to-one correspondences, cycles, repetitions, symmetries in the buildings that we design. We have them in 3D. Then we take those organizations that we impose on the world and we deliberately turn them into diagrams. So the boxes and orders get turned into the periodic table, one of the most brilliant visual representations of humankind, still productive. We use those boxes and rows and columns to turn them into turntables and schedules of all sorts. Again, boxes that are ordered in columns and rows. We turn them into jokes. So this is the likelihood of a computer issue being solved by reconfiguring something, re-imaging, antivirus software, uninstalling programs, other jargon, or rebooting. And this is another one, how long it took me to draw and color each of these bars. So I've coined a term called spraction. I don't know what it happens to that word in Russian, but in English, it's an amalgamation of space, action, and abstraction. So the argument is that actions in space create abstractions. You saw those rows and columns and one-to-one correspondences. They're all actions in space creating abstractions. Those actions get truncated and schematized into gestures for putting and taking and raising and moving and so forth. They get truncated and turned into gestures that are actions on thought. The abstractions that we create in space turn into diagrams that we use to communicate concrete things like maps and abstract things like chemical bonding. In addition, we don't just have abstraction, creating diagrams, creating organizations in the world, using gestures to explain abstractions. We've gone on to diagram the world. So this is an airport from above, and you can see it has indications to where planes can go, where buses can go, where service trucks can go, where they must stop, and so forth. It's controlling movement of objects by organizing it in space and then diagramming the spaces so it's clear what can move where and when. We have that for us in the world. There are bike lanes and car lanes and bus lanes, places where people can walk, places where people must stop. We've succeeded in diagramming the entire world using a spatial organization that's diagrammed on the streets in order to direct what can move where. So that's where I'll end, with thanks to my granting organizations. And again, it's late. I could talk about comics, but I think you probably have lots of questions. So I'm ready for Leah to ask the questions. Thank you.
Барбара, спасибо большое вам за лекцию. Да, вопросы действительно есть. Первый – это можно ли сделать вывод, что глухие люди, использующие жестовую речь, лучше слышащих соображают и запоминают информацию?
I'm not sure how a hearing impairment would work. in here, but our experiments have shown that when people are trying to understand hard material, they may use their hands to make models of what they're seeing. There's evidence that blind people do that. So blind children, when they're explaining something, children blind from birth, when they're explaining where things are in their room or house, or how to get from one place to another, they gesture. They have no idea that other people are seeing those gestures, what they're making of the gestures. They've never seen gestures in their life. So it's a spontaneous thing that blind children do and blind adults. The gestures pop out of their bodies, and because they can't know that the gestures are helping to communicate to other people, they must be making the gestures to help their own understanding. So they're gesturing for themselves. And in fact, other work has found that if someone is explaining something to somebody else, if I'm explaining to you how to get to my house, or even the psychological things I'm explaining, if I sit on my hands, it's harder for me to find words. So, and you see people sometimes doing this to search for a word, and that helps them. If they're sitting in their hands and can't do this sort of thing, they find it harder to search for words. So hearing impaired people, severely hearing impaired people, people deaf from birth, develop a signed language, or they learn a signed language. And if they learn a signed language, that signed language is as good as any other language. It uses characteristics of space in elegant ways. Different signed languages use it differently. And Karen Emery, amongst other people, has studied that. Now a lot of people are studying it all over the world, but it still has all the abstract characteristics of language. It's different from gesture. In addition, hearing impaired people do gesture on top of using a signed language. And Karen Emery, who's collaborated with me on previous research, has actually tried our research paradigm on the deaf, and it found similar findings. That I don't think she's published it. I haven't seen a publication. You're reminding me that I should ask her, but she did study hearing impaired people studying these descriptions, and in fact, or people who use a sign language, and in fact, they spontaneously gesture. And when they spontaneously gesture, they remember better. So I hope that got to your question. Thank you.
Да, спасибо. Студентка написала, что хорошо было бы как раз, да, вот эти исследования прочитать и вообще провести, да, на неслышащих людей, посмотреть, как это развивается. Также вопрос тоже от слушателя. То, что человек воспринимает информацию своим существом...
I mean, she might Google Scholar, find Emery, but right, I can try to find it and send it. There's room for some.
Да, хорошо, спасибо. Вопрос, да, то, что человек воспринимает информацию всем своим существом, телом, ну, действительно доказано, да, известно, поэтому хотелось бы еще послушать ваши личные наблюдения в этом, да, ваше открытие по этой теме.
That people express with their whole bodies or understand with their whole bodies?
От слушателя вопрос именно про восприятие. Что воспринимает.
Deception. Deception I don't know a lot about, partly because there hasn't been a lot of research on it. Paul Ekman, who was one of the early people to study deception, maintained that he could pick up tiny cues when somebody was lying, but that work hasn't replicated well. So my guess is it would depend very much on individuals, at how good they are at deception, how much they're deceiving themselves, how practiced they are, because some people who are deliberately deceiving come to believe their own lies. So it's as good as truth-telling for them. So I think it's a complicated sort of thing to untangle. And I haven't followed that literature carefully, but lie detectors, for example, have been discounted by many by serious research. And even Ekman's idea that you could pick up deception in many movements of the face and eyes and body hasn't been replicated. So it's, it gets into the philosophical issues of what deception is and what a lie is. And we looked at that a little bit in studies of memory. And, people say things like, students say things like, I haven't slept more than 2 hours a night in the last week, and I've had 4 exams and 6 papers. And you don't take them at face value, that they really have only slept 2 hours a night, or that they have 6 papers and 4 exams. What you understand from that is they're stressed out, they're overburdened, they're tired, and you don't take it literally. So there are an awful, how are you? There are an awful lot of social, what you might call lies, but are they really lies? Or they're just exaggerations that are perfectly acceptable in ordinary conversation. They wouldn't be acceptable in a court of law, but they're acceptable in an ordinary conversation because people know how to discount them. They're part of the pragmatics of speaking. So even knowing what a lie is, you say to someone, you look great. It's conditioned on the fact that they haven't slept all week and so on and so forth, then they look great. But do they objectively look great? Maybe yes, maybe no. So what a lie is, what deceiving is, I think is quite complicated in and of itself. And then the research part of it is subtle.
Спасибо. Есть еще вопрос от слушателя. Мышление, по утверждению гештальт-психологов, безобразно. Поэтому то, как мыслят художники, архитекторы, не является мышлением.
So by the way, your questions are excellent. I'm really enjoying them. So my understanding of Gestalt psychology is different. It isn't that there's thought without images, but what I'm primarily interested in are spatial representations, if you will, spatial imagery. And again, blind people can have it. Artists can have spatial imagery as well as visual. There are many different kinds of imagery. And what I've been mostly talking about is spatial. Now, there was years ago, well, there have been studies of recent studies and early studies of taxi cab drivers who before devices had to memorize the cities that they were driving in and knew those cities in and out. Now you encounter drivers who are clueless, who don't know the city at all and only rely on a GPS. But once you had to know that information, it turned out that information was entirely spatial, wasn't visual. And now you can show that with brain imagery, that it's in parietal spatial areas of the brain and not in occipital. so that you can drive around the world, know the space very accurately, but it isn't a visual image, it's a spatial one. Now, you may be able to draw a map and have a visual image, but the way you do the navigation is spatial, not visual. And spatial is, or maybe only partly visual, you have to stop at red lights and things like that. But the spatial imagery is multimodal. And I think some of it, if you become self-conscious about the way you walk around town, as I am now, I'm aware that when I get into certain places in Manhattan, namely near Central Park, the wind is going to pick up. And I'm aware that on certain streets, I'm going to smell a pizza. I'm going to get the smell of pizza or the smell of some other. I'm near a bus station. I'm going to smell the diesel fuel, or the fuel. So I'm very aware that that of these other senses that keep me on track spatially. So it's not just visual. It's much more than visual imagery. I realize there are people who claim they don't have visual imagery. And years ago, Martha Farah showed very nicely, years ago, before there was this conceptual separation between visual and spatial, she showed that people who had damage in visual areas of the cortex had very low visual imagination, but maybe preserved spatial, and vice versa. And that's been shown again. So, and again, there are people without visual imagery at all. And I am curious to how they think, because I personally can't think about the brain, for example, without visualizing the parts of the brain and even pointing to it. I just pointed to occipital, to parietal and occipital. It's hard for me to think about the brain without thinking about the map of the brain. But I'm sure that I know there are really intelligent people with low visual imagery, and they think beautifully, but differently.
Спасибо большое за ответ. И последний вопрос. От чего зависит частота использования жестикуляции у разных наций, да, в разных культурах?
So that is again a topic that would be interesting to study. The sorts of gestures we've been looking at are pretty universal. You saw probably our students come from many different countries. So they're really about thinking, and they're pretty universal. Now, it's said that Italians use more gestures than other people. And in fact, in parts of Italy, there's almost a gesture language, a little bit like sign language, so that it is learned early on. There's a language in the outback of Australia where people speak mostly sitting around in circles in the sand. And while they speak, they draw. So they're drawing in the sand while they're speaking, and that's really an integral part of the language. So, and that's slightly different from gestures, but you can look at drawing as frozen gestures. So yes, there are going to be spontaneous cultural differences. Again, the things that we're studying seem to depend on what's being expressed or learned, and not so much the culture. Even within a culture, there are differences. So I'm not gesturing much while I'm speaking to you, because I'm very aware that all you're seeing is a head or a small part of me, and that most of your screen is a diagram, so you're not going to be able to see my gestures. If I'm speaking face-to-face close to someone, I'm going to gesture more. If I'm giving a speech in a big auditorium, I'm aware that I need to point to my slides to tell people where they are, big points, but I don't make gestures that I'm worried that they won't be able to see, because people in the back of the auditorium won't see me. Operas are staged to big auditoriums, and again, the gestures are big and not little. So we all adjust the way we gesture as well as the way we speak. We speak differently to babies or small children or people who don't know our language. We speak differently. So we're making adjustments even within a culture of what we do. There are certainly situations where gestures are looked on as crude. There are cultures where it's looked on, gestures are looked on as crude. And so people are taught when they're doing public speaking not to make gestures because they're considered lower class and crude. I hope those cultures are learning that gestures actually help communication and thinking, so they should be encouraged. And in fact, of course, on the stage, they are. So we all modulate the way we communicate depending on our audiences. And yes, there are cultural differences too. I mean, I think we're increasingly learning that any behavior is influenced by culture, by context, and a multitude of other things. And that includes communication of all sorts.
Барбара, спасибо вам большое за лекцию. Слушателям, нашим участникам спасибо большое за все вопросы. Мне кажется, мы с вами сегодня вместе обозначили, сколько вообще всего еще предстоит исследовать, да, сколько всего еще не открыто и уже сделано в этой теме. Я думаю, что после этой лекции мы все будем еще более осознанно использовать свою жестикуляцию, даже, возможно, для запоминания какой-то информации, да, для лучшей сдачи в дальнейшем экзаменов, да, если это касается наших студентов. Вот, поэтому предлагаю завершать. Еще раз всем большое спасибо. Напоминаю, что у нас с вами на следующей неделе, да, 7 сентября, будет следующая лекция с Чарльзом Спенсом, который будет рассказывать, да, на не менее интересную тему про осознанное потребление. Поэтому всех также ждем. Барбара, еще раз большое вам спасибо.